That will be given in standard data booklet. It will be given. Standard values will be given. Entropy will be given in the question. Okay, let's start with question 5. The question: the decomposition of a dry nitrogen pentoxide is suitable in a suitable solvent produce a nitrogen dioxide which remain in the solution and oxygen gas is given out. The overall equation for a reaction is shown. Draw a diagram of the apparatus you would use to follow the rate of this reaction and give a measurement you would take. So here, what we will do? Diagram of apparatus you will use. What apparatus we should use? If you want to measure the rate or the speed of this reaction. This is a decomposition of the gas.
We can measure the given of gas.
Sorry, decomposition of dry nitrogen solvent. It's a liquid, sorry. A liquid decomposed to produce gases. So
yeah, so we can measure the gas. The volume of the gas produced.
Yeah, so we'll measure the volume of the gas. So we can take this solvent in a conical flask with a side arm, or we can also use a test tube. We can use a conical flask with a side arm, or we can also use a test tube. And place a stopper at the top and connect a gas syringe. And it must be labeled, always label the apparatus, like mentioned conical flask, delivery tube or side arm, a gas syringe, a stopper or a bung. And give the measurement you would make. So what we'll make, we'll measure the volume of a gas given off and the time interval. Now, the rate of the rate equation for this reaction is this. So this is the overall equation and the rate equation. What are the units of K? So how we work out the unit of a K? So what will be K according to this? The K will be equals to the rate divided by the concentration of N2O5. Reactant. The rate equation, rate is directly proportional to concentration of the reactant. And now what is the unit of rate? The
Mole per dm per second.
So it will be moles per dm cube per second. That's a unit of rate. Moles per dm cube, like moles dm cube minus 3 second minus 1. And what is the unit of concentration? The unit of the concentration is moles per dm cube. So it means mole per dm cube will cancel with mole per dm cube. So what we are left with? We are left with second inverse or 1 over second. That will be the unit of this K. Is it clear?
Yes, sir.
Okay. Now, you see that according to equation, suggested mechanism is there. Like it is suggested that this is a mechanism for the reaction. The first step, N2O5 decomposed to form NO2 and NO3, and then NO2 and NO3 combine to form other products. And then the third step, label these reactions as fast or slow and explain how your labeling is consistent with the rate equation in this question. See, according to the question, the rate is directly proportional to the concentration of N2O5, means the rate determining step included N2O5. So which reaction should be slow? Because the slowest step is always a rate determining step. Is it the first, second, or third?
First one.
So first one. Because the first one involved N2O5 as a reactant, so this is a slow reaction. So this will be fast and this will also be fast. Okay. And you will mention the points. You will list the point, like example, according to rate equation, the rate is directly proportional to concentration of N2O5 and the rate equation always involve the reagent, which is you affecting the rate, and this is always the slowest step.
So,
Slowest step is always a rate determining step.
N2O5 is also present in third step, right?
No, N2O5 is present in third, but there is also NO is also present. So if this was the case, then what should be the rate equation? So,
Yeah, NO should also be there.
so in that case, it will be K times the concentration of N2O5 and the concentration of NO.
Yeah, got it.
Both should be there because these are the reactants. I will read the points which from the marking scheme as well. Like you will have an idea the distribution of the marks. So we mentioned 1 mark is for mentioning the first step is a fast, second is slow, and the third is also slow. The second mark, the slowest step, is always the rate determining step. And the third mark, that N2O5 is in the rate equation. So it means that the rate determining step, the equation, presence of N2O5 should be there. So that's how the marks are distributed. The rate constant K was calculated at different temperatures. Suggests a practical method for keeping the temperature constant. How we can keep the temperature constant?
Water bath.
So we can use a water bath. If you want to maintain a very low temperature, we can use a ice bath. Even oil bath is also acceptable. Ice bath is acceptable. Then we have the table shows, this is a very common question in exam, that they ask you to plot a graph between 1 over T and ln K. So the table shows the measurement, and using this you have to work out the activation energy. So the table shows a measurement for a rate constant at different temperatures. Some of the corresponding values for a reciprocal of a temperature and ln K are shown. Complete the table by calculating the missing values. So how you work out the missing value? You have the value of a K. You just have to take 1 over K, like 1 divided by 320, you will get this value. And then you have the K, like 8.65 exponent minus 4. Take ln, you will get the value for ln K. And then plot a graph for ln K. So when we plot a graph for ln K on y-axis, so we have the formula y is equals to mx plus c. Okay. So on y-axis, if we plot ln K on a graph, and on x-axis, if we have 1 over t, what will be our gradient? Our gradient will be equals to EA over R. See the weightage of the mark, like the weightage of this question, 7 marks. So it's a high weightage for the question, like plotting a graph. And then EA is there. So if we need EA, the gradient multiplied by R, we'll get the value for activation energy. Because on the next one, you have the grid, and using this grid, you will take 1 over T on x-axis and ln K on y-axis. And the value of the ln K are negative values. So it means you have to take negative axis only. No need for, because ln K values are negative. So when you take label the graph, on y-axis you have ln K. So this will be ln K, a negative axis of ln K, okay? And 1 over T on x-axis. So this is 1 over T, and this one will be ln K. Yeah. Below 0, like below the x-axis, you will have this graph. And the graph will not start from origin. It will be somewhat like this. Because so it will be, because there is a y-intercept for this graph, so that's why I'm saying it should not start with origin. Somewhat when you select a proper scale, it will be like that. And then work out the gradient of this line, and gradient multiplied by the gas constant, you will get the activation energy. Question 6. Iodine react with propanol in the presence of a catalyst. Dilute sulfuric acid is used as a catalyst. The student carried out a rate of investigation of this reaction. In each set of experiments, the initial concentration of one substance is varied, and initial concentration of other two were kept constant. Like this is the initial rate method. We keep one same, we keep on changing one, and the other we kept same. First set, the initial concentration of a propanol was varied. The second set, the initial concentration of iodine was varied. And the third set, the initial concentration of hydrochloric acid was varied. hydrochloric acid, even though it is mentioned, it is in the is a catalyst, but if it was acting like student investigating in the presence of catalyst, dilute hydrochloric acid. So hydrochloric acid is actually a catalyst also, and its presence also affect the rate of reaction. So it is also in a rate determining step, because the amount of catalyst can alter the rate of reaction. So what is the relation between, remember?
So if it, sorry,
Yes,
sir. So if the catalyst does affect the rate of the reaction, so we will write it in the rate equation?
yes, it should be there in the rate equation.
Okay.
Because look, the rate is proportional to concentration of the reactant, and if the involvement of the catalyst is there, by what factor it affect, that we'll know. Like example, if it is first order, second order, third order. So here
Yeah,
the rate and the concentration are directly proportional. So what does it mean? Which order is this?
this first order.
First order. If it was a second order, when you double the concentration, rate will be 4 times. It will be like this. And if
Yeah,
it was what is the iodine? Zero order.
zero order. Yeah.
And what is with respect to acid? Also first order. So if I
First
want to
order.
write the rate equation, what should be the rate equation? So it means rate should be equals to K times the concentration of propanol CH3CO CH3, and the concentration of acid, both first order. And iodine, if you write, then write the power zero. It means it's a zero order with respect to iodine. Or if you don't write, that's also fine. Yes. Yeah. Yes. This
Sir, we'll
process.
just write H plus for the acid.
Yes.
We'll just write H plus for the acid, not
Yeah,
HCl.
because we are changing the concentration of H plus ion in the acid. Like, and if we are changing the concentration of acid, means we are changing the concentration of hydrogen ion. That's why we just write H plus, not the
Okay,
full compound.
got it.
Second order, if it was second order, then if you double the concentration, rate will be 4 times.
Yeah, and I put that in the graph of the curve where the half time is like varies between.
Yeah, initially it's shorter, then it become longer. If it was a first order, the concentration time graph, the half-life will be constant.
Yeah.
For the second set of experiments, state a practical method for following the progress of this reaction. Indicate which substance is being monitored by your method. Like, if I want to monitor the rate of this reaction, whenever iodine is there, so what we can use
Start.
titrate with thiosulfate. Like we can take out the sample, quench.
Yeah,
We can quench. How we can quench? By adding a carbonate here, because acid was there as a catalyst. So we want to reduce the rate of reaction. So we can add take a sample, titrate with sodium thiosulfate, take a sample at a certain time intervals, quench, and then titrate with sodium thiosulfate. Or there's also another way, iodine is there. So the presence of the iodine, if it is turning, so what it will do, the amount of the light which is passing, that will also change. Colorimeter can also be used.
Because there is a color.
Iodine molecule is colored, iodide ion is colored as, because hydrogen iodide was a product. So you can mention different method. You can mention colorimeter, or you can electrical conductivity, or you can also use titration, quenching with sodium. Different methods can be used. Use a graph, reduce the order of the reaction with respect to propanone. We already did that. Propanone, iodine, and hydrogen ion, and explain your reasoning. We did that. So it's a, what? No, half-life we'll mention if the concentration graph was there. Concentration time graph, mention half-life, but not here. This is a rate and concentration graph. The next is write an equation for this reaction. So what will the rate equation, as we just did? That rate is equals to K times the concentration of propanone and the concentration of hydrogen ion. And with respect to iodine, it will be 0. In one of the experiment, the following data were collected. The concentration of propanol is given, concentration of iodine is given, hydrogen is given, and initial rate. We just need the value for rate constant and with the units. Okay.
Yep.
So how we'll do, we have this value. Here we have iodine we don't want because it's 0 order with respect to hydrogen. Ion concentration is there. We have the initial rate. This is also there. So we can just divide and get the value for K. What will be the unit of the K? Now, how to work out the, see the unit of the rate, it's moles per dm cube or mole dm cube minus 3.
Mole per dm cube per second, sir.
Yeah, because it's a rate, mole dm cube minus 3 minus 1. And this will be moles per dm cube. And this also moles per dm cube. So when we simplify this, moles per dm cube will cancel with this moles per dm cube. So here we are left with second inverse, and here we are left with mole per dm cube. This will go there in division. So this will become second inverse divided by, you don't have to solve this, you have to write. So for only 2 marks, but I'm just explaining the idea that how to work out the unit. So mole per dm cube minus 3, and then you move them in numerator. So this will become dm cube 3, mole minus 1, second minus 1. That will be the final unit of K. Because the unit of the rate is moles per dm cube second. Like mole dm cube minus 3, second minus 1. Use the rate equation to suggest the possible rate determining step in the mechanism of this reaction between iodine and propanol in the presence of dilute. So according to rate equation, like use a rate equation to suggest the possible rate determining step in the mechanism. So what will the possible rate determining step? Because in the rate determining step, actually what happened, the propanol
Reacted with hydrochloric acid.
Yeah, propanol should react with hydrogen, and this is first order, so they should react with each other. So the equation, I mean, this should be the rate determining step. The hydrogen, the proton is attracted towards the lone pair of oxygen, and this whole molecule get a negative, positive charge. Because oxygen was having a lone pair, there will be a dative bond, like this proton is attracted towards this.
Sir, in this question, can we write using words, or do we have to write
Explain the reasoning also. We have to just, like you will mention, because in the rate equation, the propanol and acid are involved. So it means the rate determining step, propanol and acid should be there only. It does not depend on iodine, so iodine should not be there.
Got it.
Yeah, slowest step, yeah. So you just explain the reason here. Then you can see iodine also form a hydrogen iodide by direct reaction. A graph is there for ln K and 1 over T. So this is already ln K and 1 over T graphs are always in this scale. Like as you can see here, the same manner. But because sometimes they ask for y-axis, so usually no, but sometimes calculate the gradient. So you have to take the two values. At least the distance between the two values should be 5 centimeter or more for accurate. 2 points should be 5 centimeter or more for accurate. So first point on x-axis will be x1. First point on y-axis y1, x1, x2, and y2. So y2 minus y1 over x2 minus x1 will give us the gradient of this graph. Then use your value of a gradient and
So they will
calculate
always give the
activation.
Arrhenius
Yes.
equation, right? They will always give the Arrhenius equation in the question,
Arrhenius
right?
equation will be given to you. You don't have to memorize, but when you do the questions, you will get used to this equation.
Yeah,
So,
yeah.
so the gradient, when we work out the gradient is activation energy divided by R. So when we work out the gradient from our graph, so it will be A over R. So if I need activation energy, so this will be the R, the gas constant value is also given, and you multiply by gradient of your graph, you will get the activation energy for this reaction, which will be in joules. Is it clear?
So the Arrhenius equation is
Clear, sir.
to find the constant, right? So from this equation, we will substitute some values so we can get.
No, don't substitute the same value. No need for substitution. You just use the gradient and that compare the gradient with E over R.
Yeah.
So the gradient will be equals to E over R. Then just multiply the gradient with R, you get EA.
Yeah, maybe substitute the value. Okay.
Yeah, y2 minus y1 over x2 minus x1.
And this
Yes.
value,
Yeah.